Okay guys, for my extra credit, I'm going to walk through lesson 13, applying genetics problem number 4. So right here I have the table listed out. So it's going to ask us what these restriction enzymes would look like on a gel for number 4A. So I've already drew out my table here. As you can see, I put a column for each reaction. So 1 is just Spam HI, 2 is E. coli, and so forth. And then I went ahead and fill out my marker on the side here. And it's just easiest to already make the table instead of having to make the table as you go along. So for reaction 1, it says that BAM HI ran to 50 base pairs, 350 base pairs, and 500 base pairs. So we're going to come down here, and we see 100s on here for our marker, and then we're going to go ahead and put a line just a little bit under that at 50. So, and then 350, it's going to be between 300 and 400, and then 500, we have one right here for that. And then 2 went to 200 and 700, so 200, and then 700 is going to be somewhere in between 500 and 1000. Let's say it's about right here. Okay, and then 3 went to 300 and 600, so we find 300. And then 600 is going to be like in between 500 and 700. And then number 4, it went to 50, 150, 200, and 500. So here's 50 again. Then 150, it's going to be between 100 and 200. Then 200, and then 500. And I like to go back and just kind of figure out where it is, obviously, and then come over. It seems to help the most. Then number 5, we've got 50, 100, 250, and then 500. And then the last one is 100, 200, and 600. And just like as you go along, you can compare and be like, okay, well, I have 350, so those should be like in about the same spot and so forth. But that part's pretty easy, so let's go ahead and move on to 4B. So 4B is a little bit trickier because you have to kind of put a puzzle together. But what I found is like the easiest thing is to come up here and to look at our chart. And it looks like E. coli and HIND3, they only produce two fragments. So they're only going to have one site, or on like a linear restriction map, they're just going to have one line. So 200 and 700 for the one and 300 and 600 for the one. That's going to mean that the whole map is going to be to 900, because 600 plus 300 is 900 and 700 plus 200 is 900. So I like to come down and I'm going to say, okay, well, let's just put 900 over here and 0 over here, so we can kind of keep track of things and don't make sure we like go over or under or whatever. And then I'm going to go ahead and say, okay, well, 450 is going to be about the middle. We want to find a line to split it into 200, and that would leave 700 left, and then 300, and that would leave 600 left. So I'm going to say 200 is going to be about right here. And I'm going to say 100 is going to be about here. And then I'm going to leave that open for a second because if you look up here at the chart, the next one says that there's a smaller fragment of 50. So let's go ahead and let's put a line like right here. So this whole thing is going to equal 200, and that's going to be, 200 there for E cori. So we're going to come down here and we're going to say E cori is going to cut right here. And then 300 was hind 3, so we're going to put that right there. And then 50, we have BAM HI. So this is 50, and then if this whole thing is 200, this is going to be 150. And then this, remember, was 200, and this was 300, so there's going to be 100 separating them. And then what's left for BAM HI is 350 and 500. So if we come down here, we're almost to 350, we're at 250. So if we add another 100, put that right there, then we're going to have BAM HI again. So we're going to say this is another 100, then we're going to say there's like 500 left. And then if we add it all up, hopefully it'll get us to 900, let's see, 500, 600, 700, 850, 900, yeah. So another way to make sure that you did it right is to come up and we're going to look at reaction 4, 5, and 6. And if we come down here and look at, okay, let's say E cori and BAM H1 were used, then we're going to find BAM H1, E cori, and BAM H1. So just ignore this part. If we cut right here, we would have a little 50 segment. If we cut right here, we would have a 150 segment. And if we cut right here, we'd have a 200 and a 500. And then if we come up here and say, oh, yep, 50, 150, 200, and 500, then we know that we did it right. And you can go back and check the other ones too. So that's kind of how I do it, and I don't know, there might be simpler ways or there might be a different way for you to do it, but like I said, it's kind of just like a puzzle and you just have to keep going back over it and like check and make sure they all fit in and make sense. Okay, so then let's move on to C. It says, what are the predicted fragment lengths if this linear DNA molecule is cleaved with all 3 molecules simultaneously? So this just means, like, instead of doing 2, we're going to do 3. So every single place where there's a line, we're going to cut. So if we cut the BAM HIs, we're going to have 500 on one side and we're going to have a 50. And then if we cut the ones in the middle, we're going to have a 150 segment, 2 100 segments, and yeah, that's it. So one thing to note is that you don't have to put 100 twice because for the purposes here, it's just going to run to the same spot, so there's just going to be one line at 100, so you don't have to write it twice. So our answer for 4C, let me write it over here, is going to be